UV visible spectroscopy and IR spectroscopy is important, useful tool for identification and estimation of molecules in analytical chemistry especially. This is the graph of UV spectroscopy. It is a very simple graph. It shows up some broad peaks, and this graph is absorbance versus wave number or wavelength. Here lambda max is used, the particular wavelength where maximum absorbance is shown. Now this UV spectroscopy uses electromagnetic radiation from 200 nanometer to 800 nanometer, and the absorption happens because of electron transition from ground state to excited state, and electrons like pi electrons of conjugation or n electrons or sigma electrons are involved. Because the difference is so huge that a very broad simple graph is obtained, and this is especially useful for quantitative estimation of the compounds. Whereas IR spectroscopy graph is transmittance versus wave numbers, and the graph is comparatively more complex. A lot of peaks are seen. The wavelength used is 700 nanometer to 1 millimeter, and the absorption happens because of vibrational transitions. The bonds are stretching, bending, different stretching and bendings are there, and when the IR frequency matches with that frequency of stretching and bending, absorption happens, and we see this kind of complex graph. But this graph, which is complex, showing sharp and broad peaks, are very useful for identification of functional groups because they are having particular vibrational frequency. So absorption clearly indicates which functional groups are there. So this is very useful for qualitative estimation. This is very useful for quantitative estimation, and both are important spectroscopy in analytical chemistry.